Hello everyone, welcome to the next session on algorithmic problem solving. In this session, we will be looking at the following problem. So we have an array of integers and we would like to find the leaders in this array. So the leaders are elements which are larger than the ones on its right. So let us look at the lesson.
The input to the problem is an array of integers. The output are the leaders in the array, that is, elements with only smaller elements to the right. An example is a row of buildings from west to east. Leaders are those buildings which are taller than the ones to the east. Therefore, rooftops of such buildings have good sunrise views. Let us look at an example. 82 is a leader, since it is greater than all integers to its right. For is not a leader, since it is less than 43. 43 is not a leader, since it is less than 55. 55 is a leader, since it is greater than all integers to its right. 12 is not a leader, since it is less than 15. 15 is a leader, since it is greater than all integers to its right. 9 is a leader, since it is greater than all integers to its right. 3 is trivially a leader. In this example, 82, 55, 15, 9 and 3 are leaders. We summarize the ideas illustrated through the previous example as a simple algorithm. For each index I, check to the right for any j such that a j is greater than or equal to a I. If no such j exists, a I is a leader. Note that such a j may be found anywhere to the right of I. The check for each I takes order n time. Hence, overall, this is an order n square algorithm. Consider the idea for a more efficient algorithm. We illustrate this through an example. We process the elements from east to west, that is right to left. The first element is 3, which is trivially a leader. The next element is 9, which is a leader, since 9 greater than 3. The next element is 15, which is a leader, since 15 greater than 9. The next element is 12, and 12 less than 15. Hence 12 is not a leader. The next element is 55, which is a leader, since 55 is greater than 12, 15, 9 and 3. The next element is 43, which is not a leader. The next element is 4, which is not a leader. The next element is 82, which is a leader. 82 is greater than 4, 43, 55, 12, 9 and 3. This array has 5 leaders, that is 82, 55, 15, 9 and 3 in index positions 0, 3, 5, 6 and 7 respectively. The plot shows the values on the y-axis and the index positions on the x-axis. The leaders are shown in red, the rest of the elements in blue. Note that as we move from right to left, each leader is taller than the previous leader. Also, in the right to left order, any element which is taller than the last detected leader is also a leader. Here is the pseudocode and the Python code snippet to implement this algorithm. We scan the array from right to left. The variable m tracks the largest value seen so far. If the current value is greater than m, we update m to the greater value. It also means that the current value is greater than the maximum to the right, and so needs to be reported as a leader. The algorithm takes O(n) time. It needs only O(1) extra space beyond what is used for storing the input. A quick question. We presented 2 algorithms for the leaders in an array problem. Which of the 2 algorithms works in order n time, assuming the input array comes pre-sorted? Option A, left to right scan. Option B, right to left scan. Option C, both the algorithms. Option D, neither of the 2. The correct answer is option B, the algorithm involving the right to left scan. Another question. What is the complexity of the first algorithm when the input is sorted versus when it is unsorted? Option A, order n in both cases. Option B, order n when sorted, order n log n otherwise. Option C, order n log n in both cases. Option D, order n square in both cases. The correct answer is Option D, order n square in both cases. Thank you. This course is brought to you by Elahay Technologies.